Alrighty, let's see what we have here. Maximize active section with trade part 1 medium. You're given integer or a binary string s of length n, where 1 represents an active section, 0 represents an inactive section. You can perform at most one trade to maximize the number of active sessions in s. In a trade, you can convert a contiguous block of zeros that's surrounded by a contiguous block of ones that's surrounded by zeros to all zeros. Afterward, convert to a contiguous block of zeros that's surrounded by ones to all ones. Return the maximum number of active sections in S after making the optimal trade. Note, treat S as if it is augmented with ones at both ends, forming T equals 1 plus S plus 1. The augmented ones do not contribute to the final count. Maximize the number of active sessions. Afterwards, convert zeros that's surrounded by ones to ones. That seems like it would not actually increase the number of active sections. Oh, like the count, not the, it's the number ones maybe? Because there's no block of ones surrounded by zeros. No valid trade is possible with the number of active sessions as 1. String augmented. So you put ones on the ends. Choose to convert. Because it needs to be a contiguous block of ones that is surrounded by zeros to all zeros. And then this is all ones. Okay, the number of active sections. So each one is an active session, not a group of ones is an active section. Okay, yeah. So I want to say these zeros get converted. Augmented. Say what? Oh, okay. This is a whole section that you can, no, that's a whole block of zeros surrounding 1 or multiple ones. Okay, and then basically convert all that to ones. Okay. Okay, seems simple enough. I think I just want to start with the augmentation. I think I also just want to have an array of ones and zeros, right? No need to make this fancy. So I'll call these bits, I guess. And then, actually, how do I want to do this? Actually, I think I'm just going to keep it. I'm going to just convert the string into a binary array, binary integer array. I'll call these bits. I'll use list comprehension to convert it. So it'd be maybe converting the 1 to 1, character 1 to letter 1. So I think it's just that integer value of the character k for every k in S. I think that's the syntax for it. Just go ahead and verify. Okay, that looks fine. And then I think to use the wraparound function or wraparound indexing in Python. So I'll use bits.append 1, which means if I do -1 as index, it's going to be also 1. And then I just need to find the longest contiguous block, I think. Looks probably Probably sliding window. Because like what I care about is the sum, the number of zeros. I want to convert the most zeros to ones, right? I want to convert the most zeros to one. And the way that this works would be, it would have to be each kind of block of zero, separated by some number of ones. Each block of zero separated by a block of one. Two consecutive of those would be the things that are converted to all. The ones between them would convert to all zeros, and then they in they then are converted back to ones. But the net of that is just the zeros themselves are converted, right? So it's initially two ones and five zeros. These two blocks of zeros, there's five zeros, and within them, they all become one. And so the answer is 7. So it's just the sum of the counts of two consecutive blocks of zeros that were two consecutive blocks of zeros surrounding a block of ones. So it's just the maximum value of that I can find within the bits of the array or string. So I think maybe um, I think maybe I'll just say current is equal to negative infinity, and then I'll iterate over. I wonder if I can just use. I wonder if I can just use some built-in function to delimit the string. Like if I use a delimiter in string. What is the syntax? Delimit string Python. Kind of break apart. Because I want to basically, okay, split, that's right. Split based on ones, I think. Split by custom delimiter. Okay. I think this might actually just be simpler than this. Okay, so it'd be s.split based on ones. Is that going to return the array? Yeah. And I think I'll just call these blocks. Okay. Okay. And then I just need to find two consecutive ones. And it's possible that the blocking can have a starting or ending that's empty because it has has a starting or ending 1 where there's no 0 before or after it. Okay, so I think so. How should I? So I basically just find the length of each block as the number of zeros. I could even use a list comprehension here. No, no. Um, I could actually. I could do something like I don't know. I don't know if this would be taking more space though. I'm not sure how fast this is, to be honest. This might be too slow. It might be better just to do the for loop that iterates over every index using bits here. Yeah, I don't know. Okay. Let's just try this out. Um, for k in range, say start is I guess if the number of blocks is guess if the last block is empty. How to do this? There's always going to be two elements within this, right? Because even if the test case was just a single one or a group of ones, it'll be zero or be empty string before and empty string after. Kind of want to get rid of the empty strings. I don't want to get rid of the empty strings. Well, I definitely need to not consider it. Current equals length of the first element, length of blocks is 0. If current equals 0, then technically that's an empty string. So current becomes equals to make it maybe negative infinity because then I don't want to use it. And this code is so much simpler than what I'm thinking of. Okay, actually, this is just too fancy by half. Let's just go bits appends 1. I think current is negative infinity is fine. I just need to count streaks. So for every index k in range n, where n is the length of the string, I guess the length of bits maybe. Length of bits. Wait, maybe I should just. I need to append a 1 actually. Say previous is actually negative infinity. And the current is equal to 0. So current is the current streak of zeros in block. So I think here, if the bit set k is equal to 1, skip it. Is it skip it? That's not true. If it's 1, then it needs to end. Oh my god. What is the fastest way of doing this? if the length of bits is for every index in bits, if it's a 1, generally if I deal with streaks, then I wait until it transitions, right? I guess if it's equal to 1 and there is a current, and there is a current streak of zeros, or if there is, and the current streak is of 0 is 0, so that means it's all ones, then skip. Okay. But if it's 1, if it's a 1 and the current streak of zeros is not 0, so that means it's ending a current streak of zeros, then the answer needs to be max, or answer is maybe negative infinity right now. Or maybe answer should just be 0. Initially, answer equals max of previous plus the current streak versus answer. And then current streak becomes equal to 0. Okay. Else, or actually, sorry, previous becomes current, and current becomes equal to 0. Yeah. And then otherwise, if the current bits is 1, then just increment the current streak. I think that's right. And then I reach the ending. The ending is automatically always going to be, maybe I should be ending with a 1 then. Yeah, maybe I should always be ending with a 1 then. And then this could be it. Fuck. Oh, what? Yeah. Okay, so answer is now equal to the maximum things that I convert. So it'd be answer plus the number of ones that are already in there, plus what's the syntax for count? It'd be bits dot count one minus 1, I think. Yeah, because the minus 1 is just because I appended an extra 1 here. Fuck. Fudge him about it. Okay, I think maybe this list comprehension is probably not necessary. I could probably just iterate over the string. Can I do append on a string? Can I do that? Oh, it creates a brand new string. Okay, I don't want to do that. In that case, you convert that to that, and I need to handle the case at the end where it has 2 consecutive blocks at the end that doesn't end with a 1 separately. So I think it should be answer equals max of previous plus current. Okay, is length of string at this point. No more bits. This should be string. Okay. String count 1. Whoops, strings count character 1. I could. Oh boy, how did I get that wrong? The previous is negative infinity. Current is 0. Current is 0. And then it hits the okay, I think maybe this should be if the current not equal to 0. So if it ends at the 1, so if the current is not equal to 0, then that means it ends with a string of 1s. Current not equal to 0. Current equals 0, then ends with a string of 1s. But if that doesn't work, I think that's the correct logic. All right, I'm done. So, summary overall, the simplified logic for this is 2 consecutive blocks of 0 can eventually be converted to all 1s. So answer equals count of 1s originally plus count of 0s within those blocks. Just need to iterate over the string counting streaks of 0s. Basically, those would be the blocks of 0s. And finding kind of the highest consecutive blocks. So answer here is originally highest total of or total / length of 2 consecutive blocks of 0. And then eventually you add the 1s into it because that's going to give you all your sections or all your active sessions of 1. Find the highest consecutive blocks of 0s. Be careful of edge cases, like particularly test case 1, because technically if it ends in a 1 or starts in a 1 or ends or starts in a block of 1s, then the logic needs to handle that. All right, time complexity is going to be O of n, since the loop will iterate over each index once. Yeah, and then space complexity, this is going to be O of 1, since no extra space is needed. All right, means